Hi everyone, in this episode, we'll explore evolutionary libraries in chemistry, a powerful way to generate and optimize new molecules using DataWarrior. An evolutionary library is a way to generate new chemical compounds starting from one or more parent molecules. The idea is to mimic evolution at the molecular level, introducing modifications to explore the chemical space around those parents. In this process, molecules are evaluated through fitness-driven selection, for example, drug likeness, activity, or other profiles. Often, multiple objectives are optimized at the same time, such as potency and safety. This approach matters because instead of blindly searching an enormous chemical universe, we can rationally explore promising regions, making lead discovery and optimization more efficient. To begin building our evolutionary library, we first need a starting compound. You can use any molecule, but in this example, we'll reuse one from our previous tutorial on phosphodiesterase 5A. What we need here is only the 2D structure. To copy it, go to the structure table, right-click on the molecule or control. Click and select Copy Structure as 2D structure as shown on the screen. Next, let's build the evolutionary library. From the top menu, go to Chemistry and select Build Evolutionary Library. A new window will open, and for this demonstration, we'll start simple by deleting the default molecules that appear. Remember, there are many different ways to run DataWarrior, so you'll need to experiment depending on your project. What I'm showing here is just one small example. So, after removing all the default 2D structures, we paste in the molecule we just copied. Once it appears in the window, we can edit it simply by double-clicking on the picture of the molecule. This will allow us to refine our strategy for the evolutionary library generation. Now, in the structure editor window, we select the lasso tool. With this tool, we can highlight parts of the molecule that we don't want to change during the evolutionary process. Once selected, that region turns red, indicating it will remain fixed. We now have our starting compound, with part of it frozen. Let's add our first constraint, a value range for log p. Click on Add Criterion, set log p to be less than 4, and keep the default weight at 1. Next, we'll add a second constraint based on compound similarity. Using scale sphere fingerprints, we want the generated molecules to remain close to the starting structure. To do this, paste the copied molecule into the small window using Control, Click, and Paste. For this constraint, we'll adjust the weight slider to about 0.5. All other parameters can stay at their default values, but notice there are many options you can explore. In this simple example, the run produced almost 300 molecules. A new window now appears, showing the generated molecules. Alongside the structures, you can also see detailed information for each compound, such as log p values, the fitness function scores, and other calculated properties. The fitness function is essentially a measure of how well each compound matches the criteria we defined. For example, staying below a certain log p or maintaining similarity to the starting molecule. In other words, the higher the fitness value, the better the compound fits the design objectives. We can of course run these computations again using many other constraints, depending on the design goals. Once the new compounds are generated, we can extend the analysis further. For example, we can compute Lipinski's rule of 5, generate 3D structures, or even dock the new molecules into a target protein. It's also possible to check whether these compounds already exist in databases like ChemBL. In short, the evolutionary library is just the starting point for a wide range of downstream analyses. Drug discovery is an incredibly challenging journey. Even with powerful tools like DataWarrior, designing better compounds is far from simple. Many questions remain, for example, can a proposed compound actually be synthesized? Even with information provided in DataWarrior, or with synthetic accessibility scores such as those available in RDKit and other toolkits, this remains a difficult task. Still, approaches like evolutionary libraries can play a valuable role. They don't provide the final answer, but they can spark new ideas and help guide the search for promising molecules. That's all for today. Thank you for following along. I hope this introductory tutorial gave you a clearer view of how evolutionary libraries can inspire innovation in drug discovery. I'll be sharing more tutorials as we continue exploring DataWarrior and its powerful features. Until next time, take care.